Good afternoon, everyone. Hope you are doing good today and you have enjoyed previous lectures. Today, I'm going to be discussing about how to analyze algorithms. So, have fun. What do we mean by analysis of algorithms? In simple way, we want to know or we have some kind of expectation that how much memory our program is going to take and how long our program is going to run. Interesting. So essentially, we would be by analysis means that we would be predicting that what are the resource requirements and what are the time requirements for an algorithm to execute. We would be making some small assumptions that um, all the instructions are executed one by one. Now, we are not considering here that the instructions are executed in parallel. Say, for example, if you're writing an algorithm for a GPU graphics processing unit where you have hundreds of processing units, they can execute the tasks in parallel. So we're not considering that. Here, for simplicity, we are assuming that each instruction will execute it in sequence. So we are mainly concerned with two kinds of analysis. So first one, like we want to know what are the resource requirement, or in other words, how much memory the program is expected to take. Second, how long the program is expected to run, or how long your algorithm is supposed to run before it produces the results, or total runtime of an algorithm. So let's focus about an important aspect first about runtime analysis. So we want to know how fast or how slow our program is, what is the upper bound and what is the lower bound. So let's go back to the insertion sort algorithm we did in previous lecture. Those who haven't seen my previous lecture, I would encourage you to watch the video about insertion sort algorithm. So in this lecture, we're gonna be focusing on the time complexity, or in other words, how much time our insertion sort algorithm will take. Now it depends. If you already have a sorted list, it may take less time. If you have, say for example, list which is sorted in a reverse way, it might take maximum time. And if some elements are in order, some elements are not in order in the list, it might take some time in between, because here we are executing the while loop. So this condition depends, like if your whole list is sorted, then only this condition, the while test condition, will be executed. No other statements, say statement number 6 and 7, will be executed in the loop. But say if your input list is sorted in a reverse order, then this test condition, while loop test condition, and while loop body statements will be executed for the maximum that is we're going to be calculating. So for the worst case scenario. So let's say here how some assumptions. Let's say n is the length of the array, or r length of the list. Now tj denotes the number of times this while loop in statement number 5 is executed for that value of the j. Okay, so now let's see step number 1, statement first, for loop. It will be executed, the cost of executing is c1, it will be executed n times. Step number 2, The cost, here cost means that how much time the processor will take to execute this statement. So we don't know, but let's assume some constant C2, because this is just one line of a statement. So it's gonna be executed in a constant time. But how many times? N minus 1. Similarly, we go to line number 3. Here the comments, we assume that the computer is not gonna execute the comment line. So the cost associated with the comment line is 0. How many times this line will come? N minus 1. Now statement number 4, cost associated, same way, like we assume some fixed cost because this is just one statement here. And how many times it will be executed? N minus 1. Now for this while loop, it's tricky. So it's at the statement number 5 or step number 5, this test condition will be executed by this expression, j summation of all the times tj from 2 to n. Now the statements within the while loop body will be executed by this expression. I hope you can see it clearly. And then last statement, statement number 8, in constant time, but how many times? N minus 1. So we try to find out how many times each statement will be executed. What are the constants? What are the variable? Good. Now finally, the running time of an algorithm would be the summation of all running times of all states executed. So for example, for the insertion sort, we're gonna sum all the times. So what would be the total time for, say, line number 1 would be C1 multiplied by n. C1 is the cost of one cost of the say unit cost of one time execution, but this statement will be executed n times. So total cost would be C1 multiplied by n. In the same way, we just get the total cost for each statement to be executed, and we come with this expression, C1n plus C2n minus 1. It's very simple. You just multiply cost with the time. Good. So far so good. Hope you are with me. Good. Now let's say we have this expression. Now here tj time is variable. For example, C5, it denotes the step number 5 or line number 5 while test condition. Say if our list is sorted already, then only this statement will be executed n times, and the while loop body will not be executed. So C6 is multiplied by 0 and C7 is multiplied by 0, and the last statement will be executed. So we can say that is our best case, in which the list is sorted and we calculate C1n plus C2n minus 1 plus C4n minus 1 plus C5n minus 1, C8n minus 1. So that becomes the linear function of n. So our best case time complexity comes as a linear function of n. This funny symbol omega, this denotes that our best case time complexity is of order n. Simple. There is no complexity here. Good. Now let's say if our list is sorted in a reverse order. Say if we wanna sort a list in ascending order, say 1, 2, 3, 4, 5, but we have given input in the other way around, like 5, 4, 3, 2, 1. So that becomes like worst case, like um, each number in the list would have to be swapped. If we go back to the insertion sort algorithm in the previous lecture, you'll come to know what I mean to say here. So let's try here. So for the worst case time complexity, so C1n, those are constant time steps, just depends on the function, the n, how many times it's gonna be executed, the size of our input. The tricky part starts here, the tj. So if we do the sum, this comes down to n into n plus 1 divided by 2. So you can do summation and you can do little mathematics, and we come up with this equation. If we try to solve further, we finally get the equation in the form of a constant n square plus bn plus c. So this is a quadratic equation. So what is the upper bound here? Is the n square. So we, in simple terms, we say that this becomes our worst case time, right? Or in other words, to give an order of the time complexity, we denote it with theta h n square, big theta of n square. That becomes the upper bound. But in practical cases, your running time of insertion sort algorithm would be in between omega and theta, omega n and theta n square. So this gives an idea that if say you have list of say 5 numbers, right? So worst case 5 square. But think about if you have list of 1 million numbers, how many times it will be executed? Square of 1 million, right? Not very efficient. Good. It's not good. It's not very efficient when we have the input size enormously large. So our main objective when we design the algorithms, we try to come up with the algorithm which has linear or approximately linear time complexity or linear time of execution. For certain problems it is difficult. We go on a different routes like randomized algorithms or optimized. We try to optimize algorithms in different ways. But for now, for this lecture, just keep this in mind, that how we analyze the runtime of algorithms. If you have any questions, you can send me an email, and do not forget to subscribe LeProfesseur YouTube channel. If you need private tuitions or you need any help, you may contact me at hr@leprofesseur.org. Hope you have a wonderful day. Thank you.